Hello, welcome back to Blender Sushi Live Noding. In this episode, we're gonna take a look at the creations of this kind of like a wave sculpture. So I will actually start from scratch instead of just giving you the node tree because it's better as a story. So let's use the node. This is actually the nodes that's responsible sine oscillator, but this can be actually all kind of different oscillator. The four most famous wave curve oscillator. So basically, let's save this first. SVOSC for oscillator. So this node actually kind of expecting some kind of input and it's gonna output something. Let's try the stethoscope and take a look. So there's a value, there's a period, phase, amplitude. So the value, what is this value for? So basically we can try if we have vector input and we have some kind of value and we want to see how it reacts. So the value may be like a number. Plug in the value, plug this into the X, and try using something like viewer draw. And this vector goes into the matrix like a transform. And you can see it's giving you a wave. Okay, so that's really interesting, right? Because you can plug in like something like a box, and you're gonna end up with the animations right away. And the animation is like a wave because we are using the sine oscillator, but it can be also square, so it goes like on off on off. Can be a saw, it's like a slide slopes, can be triangles. So that's interesting. And we have also custom, but the custom is expecting some kind of wave. So that's interesting, but let's see if we can do this better. Let's use the sine oscillator. So we're gonna make some kind of sine wave. And for the value, instead of just using a single value, we can use range of number. And range of number, of course, is just range of number from whatever value into whatever value with a step. You can have different modes. Let's plug this in. And just like before, we have this number range, we have this sine oscillator, but we're gonna end up with multiple value here. It looks like it's 1 1 1 1 1. Okay, that's means it's just like gonna be like a flat line. Let's try actually use step and or actually step or count. Count is probably better. So we have the minimum and maximum and the value in between, and then we use vector in. So we have this number that represents the X, and the output is going to be the Z. And let's take a look. Okay, now we're getting something. It's kind of like a wave, right? If we can't see, it's just like a bunch of points. We can increase the number of points. Okay, now we are actually seeing something. To be more clear, we can actually turn this into polygon edge. So use the UV connections, enable edge. As the result, we have points and edge. And we can always bake this out. So that's okay, that's cool. Now we can really play around with these nodes finally. So we have the setup. We can control the amplitude, control the period, and in the phase, the offset, And yeah, and we can try using different wave functions, and then it's triangle. So this is cool. And then we also have custom. We're gonna leave it for the last. Okay, cool. Now that we have all this, we can actually use other things like extrude edges. So because we have vertices and edges information, we can now output some kind of extrusion. Okay, let's extrude it in the y-axis. Okay, cool. So we can still have everything cool. All right. On top of this, after we extrude edge in the y, maybe we want to solidify this further, so we can extrude, maybe extrude region. With extrude region, we can try by matrix or along the normal. Let's try this matrix thing. This one might be a little bit heavy to calculate, but we can try anyway. Okay, so we can extrude it up or extrude it down, but be careful, it might be like the opposite of the normal, so it's the result of this might be kind of inverted. Oh no, it's not. Cool. So this is nice. We have wave. We can actually scale this, the bottom part. If you use 0, it's gonna give you error. So just give it like 0.0001. So it's almost flat. So this is nice, I think. Now we can play around with the amplitude, period. And this is like a lot of points. We can reduce it. 100 points, 50 points even. Now we can actually try using frame info, plug into the face. Okay. This needs to be rounded, or we can use evaluate. So it's like evaluate is like based on the frame number, maybe 1 to 100. It's gonna go from 0 to 1. This is what evaluate does. So now we have these animations. I believe this is actually looping by default. And yeah, I think this is pretty much it, except that we haven't used custom. So with custom, of course, let's say we have a number, right? Integer. Give it like 80. Plug this in. So with this number, we can create a line. And we can plug this line into the noise, vector noise maybe, so that this guy can generate some kind of wave functions. And this is what we have. So we can use Perlin or Voronoi or cell noise, the usual. And we can play around with this. Normally, to have more control of this, we can use vector math and multiply by scalar. Or actually, in this case, we don't see much of the noise. Maybe I need to increase the value. Right. Cell noise, Perlin, Voronoi. Seems to be repeating somehow. But that's actually basically that's the in the nutshell that's what this custom oscillator node can do. So there's a lot of nodes now and seems complicated, but it's not really, because you already know how this actually works. So if you want to output something, you use bmesh. So viewer bmesh. Instead of this viewer draw, you output an actual object, and you can actually render this out. Turn on cavity, give it a nice matte cap. Yeah, and then you can actually bake this out. File, export, bake as Alembic. It's gonna be faster. Normally, yeah, this should work unless you probably need to force it. Yeah, maybe turn on displacement, turn this off, file, export, Alembic. This should actually work. It might not work unless you use animation nodes to force export this, but we'll see. Oh yeah, it's actually working, which is kind of interesting. And this thing is actually looping if you kill one frame at the end. Yeah, I think this is kind of nice. Yeah, so anyway, so let's have a final look. You started with just this custom oscillator, or start with this oscillator node, and then you kind of solidify this, you turn this value into line that you extrude and extrude down, solidify it, and you're gonna end up with this. But yeah, I think the whole thing is actually made a nice setup. So hopefully you find this interesting. But this oscillator is really powerful nodes, even though it's really simple. You can use this for a lot of things. Anything that moves in a wave kind of pattern, you can actually simply use this node to animate it. So it's really useful for motion graphics. Besides sine oscillator, this one also can be used, you know, like to make some kind of rotation motion, going up and down. So a lot of things, actually procedural, is really based on sine oscillator. All right, so thanks again for tuning in, and I'll see you next time. Thank you. Bye.